Alright guys, in my last video I talked about the amplitude of a trig function, and this one I'm going to say talk about the vertical shift. And so let's just jump right into it. Remember that the original sine graph looks like this, and you heard me in class say that it starts at the origin, it tops out at -1, and then again it takes 360 degrees to get from beginning to end. So this is sine x. And then similarly, we've got cosine x that still has the same top and bottom, but at 0 degrees it's at 1. And you can verify that on your unit circle. And it kind of has the same curve, but it starts and ends differently. It ends and starts at a high point. So this is your cosine x. So when we talk about a vertical shift, we want to think about when there's a number separate from the actual sine function. That number is going to shift it up or down so many units. When it's positive, it's going to shift it up, and when it's negative, it's going to shift it down. So one thing to kind of think about is when the original graph kind of wraps around the x-axis, when you shift it up 4 units, it's like all these points, look to the left of the screen, these points are all getting shifted up 4. So the origin used to be the starting point, but now everything is going to get shifted up 4. What I encourage you to do is draw a little dashed line at the spot that corresponds with the shift. This is kind of it's like your new x-axis. It's actually called the midline. Slide this over a tiny bit. Midline. And the idea is, instead of going up 1 and down 1, you're still doing that, but you're essentially starting 4 units up. And again, everything's been shifted up 4. And that's what the vertical shift does. Let me do another quick one with cosine. Let's say we have a negative vertical shift. Now we're working with cosine. Another way to do it is say, okay, that vertical shift tells me that my new x-axis, my midline, is going to be down here at -3. But let me switch to my color. Cosine doesn't start on the midline. Cosine starts at what I call a high point. So again, the old graph kind of looks like this, but all those points have been shifted down 3 units. So if this right here is the new origin, the high point's going to be right here. Then it's going to come down, go back up. That would be at 360. And then again, down, go back up, however many times you'd want to repeat this. Now, if you're not seeing the pattern, hopefully you can see it after a few more examples. But again, if you did like your traditional T-chart, wrote that incorrectly, -3 plus cosine x. And you could also think of it as cosine x minus 3. And then you use your values that are integers on the unit circle. Well, cosine of 0 is 1. And then if you subtract 3 from that, you get -2. And that's where this value is. That's where we just graphed. Cosine of 90 is 0. And then if you subtract 3 from that, you get -3. That's this spot right here. 180 is -1. Negative 3 adding to negative 1, you get that negative 4, and that's where it bottoms out. And again, you repeat this process however far you want to go. You can actually verify those points. All right, so kind of a recap so far is you've got this equation that the general equation is you have these numbers that can affect how sine and cosine look. And sine and cosine are slightly different in terms of their starting points, but they really are the same curve. They've just kind of been shifted a little bit. And so your cheat sheet so far is that this value represents the vertical shift. Same thing here. And this A represents this thing called the amplitude. This is your bread and butter right here, everybody. You can also think of the vertical shift as where your midline is, if you're a visual person. Which I think you almost have to be to do some of these graphs. All right, so that's our cheat sheet. So let's do one that has both an amplitude and a vertical shift. So let's graph y equals, let's go 5 plus 3 sine x. Again, we're trying to do this quickly, and we're trying to do it without technology, emphasizing what the 5 and the 3 do to the graph. All right, so here's what I would personally do. I look at the 5, and that's the first thing I label. And that's going to be where what I call my midline is. And that means that your curve, your sine curve, right, this curve, whoop, that's going to be wrapped around the midline. But we talked about how the amplitude is this distance. And in this case, the amplitude means that these have to be 3. And if this is 5, and it goes, up 3, and it goes down 3, well, you can kind of say, well, isn't this going to end up at 8? And, isn't this going to, if I go down 3, isn't it going to be at 2? And that's a great way to think about it, because that's the 8 is going to be the highest point, and the 2 is going to be the lowest point. We're making these numbers kind of specific on the sine curve. You could think about this is the graph coming together. We're just going to finish it up on the actual graph that we started. That's the high and that's the low. I kind of like how that played out. So back to the graph at hand. Also remember with sine, it starts at the origin, it starts in the middle. I'm going to keep saying this the next week and a half. Sine starts in the middle. So sine's going to start, boom, right in the middle. And the idea is it's going to go up to the high point, come back down to the middle. It always has the same shape. Down to the low point, back up to the middle. And we could do these pieces individually, but remember it starts at 0. Right, I'm talking about it's starting here, and then it goes around the unit circle to 90 degrees. Right, that's this point up here, right, that's 90. Then it comes around to 180. That's right here. Maybe you're thinking, hey, isn't 180 supposed to be 0? It is, except we added 5 to it. That's where that vertical shift comes up, and that's where that 5 comes in. And then we go all the way down. When we get to 360 degrees, we're back to where we started. And then you could go around the circle again if you wanted. And you get all the way here to 720. That would represent 2 times around. All right, we got time for one more. Let's do an additional one. Hopefully you're feeling better about it. Let's do one with cosine. So let's do -10. Mix it up a little bit. Plus 8 cosine x. So as we get settled in here, this is our midline, also known as the vertical shift. And this is what we're calling the amplitude. So I'm going to do a sloppy sketch here for a second. I shouldn't even draw that. So remember, your cosine graph starts high. The midline's going to be right here. And so if you're visualizing this, the midline's going to be at -10. And then you're going to have to go up. This is going to be 8 units. This is going to be 8 units. So maybe, I hope, you're thinking that, you know, that's going to go down to -18. That's going to go up to -2. And our graph's going to look something like that. So, let's do it. Let me redraw that. I'm going to shift this down a little bit. I'm going to say this is my x-axis. And then I'm going to say -10 is right here. So, draw that midline in. We use a dashed line because it's not part of the actual graph. We use a solid line to represent the actual graph. And then this amplitude means that it's going to kind of move the graph, you know, up and down 8 units in both directions. And so if you go 8 units this way and 8 units this way, you can kind of see that the range of the graph is coming together. That curve is going to stay between -2 and -18. It's kind of like your new high point and your new low point. Don't forget, with all of these, you could also make a t-chart. I won't do the whole thing because we're trying to be efficient with it. But, you know, if I have this function, x, and then I have this function -10 plus 8 cosine x, if you plug in a 0, it would be -10 plus 8 cosine 0. But cosine 0 is 1. So you'd have -10 plus 8, which is -2. So that means 0, -2 is a point on your graph. And again, check it out. Look at this shape. That's the high point, right? That's that trig. Cosine starts high. That means cosine is going to come in like this. Come back up. Boom. I'm going to hit that again. That's around the unit circle. Then it starts repeating. It's going to take 360 degrees. And again, these critical points that I'm sketching right now, these are happening every 90 degrees. You could verify these using a table, but I'm hoping you're starting to see some of the patterns. Just like when you graph lines, you could make a table, or you could use, you know, slope-intercept form and bust out the graph kind of immediately. Hey, I appreciate you guys watching, taking interest, always looking for feedback, but good luck, and I'll see you soon.